Okay, then let's begin. So today I thought of discussing the physics chapters. So not all the chapters that I could cover today, but I'll try my best to cover mostly what's being focused on the exam. Okay. I have selected some of the specific lessons from the physics chapters. Actually, not all the chapters, but not all the chapters, but what's occurring mostly. Okay. So,
Okay.
so I have selected some of the specific lessons from your physics lessons. So not all, but the mostly occurring ones I have selected. Okay. So like the mostly occurring ones in the sense when you consider heat, it occurs in the year 2022, then 21, 20, 90. So it occurs in most of the years. So there's a chance of this question coming and repeating in your exam as well. So let's see. Together with the question, I'll be discussing the theory part as well. So with that, I think you'll be able to answer all the questions and hopefully the question that you'll be focusing as well. Okay. Then, so this heat lesson is very simple. I think you'll get that in your grade 11 lessons. So it's a very simple one with a little theory. Like in the book, it seems to be large, but the theory is simple. So the question they ask is also simple. So let's begin. And if there's any issues like that, just tell me. Okay, I'm sorry for what happened.
Okay, teacher.
Okay, let's begin now. So what they have asked here is just about the diagram. They have given a description first. The diagram shows a kettle with a heating coil and it contains 1 kilogram of water. And the first question is, what is the main method of transmission of heat produced by the heating coil through the entire mass of water? So we know that there are 3 methods of heat transmission: conduction, convection, and radiation. So these are the 3 types of methods of heat transmission. So when you look at each one of these methods, first let's focus on conduction. So usually conduction happens in solid substances. For example, when you hold a metal rod to a fire, okay, let's say a fire, and you're holding a metal rod to that, and you can see that the heat from the flame will travel through the rod, and that would reach to your hand as well. So how does this happen? So let's see, these are the particles, these are the atoms of the rod, okay, the metal rod atoms. And the heat energy is actually the kinetic, vibrational kinetic energy, vibrational translational energy, you can call it as. So what happens is that we know that the atoms in solids can only vibrate. So because of the vibrations of these atoms, that energy will be transmitted from one atom to the other, and finally it will reach to your hand. So this is conduction. Okay. And we know that based on the ability to conduct, you can divide the matter into 2 as conductors and insulators. So if they can conduct heat well, you call it as conductors. And if they don't have the ability to conduct the heat, or you can say as electricity as well, that is insulators. Clear? So let's focus on the next one, that is convection. So convection, when you consider, it occurs in, it can occur in air or else in fluids, in liquids. So the actual case here is, let's say it can be air or it can be water. I'm just taking water for example here. So you have particles at the bottom and you also have particles at the top. So actually what happens here is when you provide heat, the particles at the bottom will get heated. These things will get heated. And when you heat something, their density will decrease. When you heat something, their density will decrease. And as a result of that, they move up. So this less denser particles, let's say they move up. And then as a result of that, an empty space will be created in this region. This is empty. The less dense particles has gone up. And when compared to those less denser particles, the upper particles have density and they tends to come down. So because of this, current is created, and that current is what you call as convection. Okay. So when you look at this question here, what is the main method of transmission of heat in this? Is through convection. By heating, we know the bottom particles will move up, the top particles will come down, and as a result of that, a current is created, and that's how it's getting heated. That's how the heat is getting transmitted. Okay. And the third type is radiation. So radiation is when you consider, let's say, you have a flame. From the flame, when you like, close to the flame, when you keep your hand, you feel the warmth of the flame. Not only that, from a cup of tea, the same thing. When you keep the hand on top of that warmth will reach your hand. That is due to radiation. Okay. So here the energy travels through electromagnetic radiation, electromagnetic waves. So here this example I told you now, that is the fire, the warmth from the fire, the warmth from the cup of tea reaching to your hand is just like matter is present here. That's with the help of air. But for radiation, always a matter is not needed. Sometimes you don't need a matter as well. That means, for example, from the sun, the energy from the sun will reach to the earth through the space. Space is a region where there is no matter. So that's an example where radiation occurs in the absence of matter. So I hope you all are clear with the three types of radiation. Is it clear, everyone?
Yes, teacher.
Okay.
Yes, teacher.
Okay. Now I'll move to the next one. Look at the second question here. Calculate the amount of heat received by water when the water in the kettle was heated from 25 to 50. So understand the question, okay? The same question only keeps on repeating. Calculate the amount of heat. So the question is amount of heat, okay? One and only equation that you have to apply there is Q equals MC delta T. So now I'll be explaining what each of these things mean. Okay. So we know M is mass, but it's not in grams that you have to give. You have to give it in kilograms, not grams, okay? And the next thing is you will have specific heat capacity. Okay, now I'll explain you the term heat capacity. Okay. So now heat capacity means amount of heat that is required to increase the temperature of a substance by 1 degree Celsius. Let's say if you want to increase the temperature of water by 1 degree Celsius, how much heat that you have to provide? That's what you give as heat capacity. But in this equation, find it as specific heat capacity. So specific heat capacity is for 1 degree Celsius and 1 kilogram of a substance. So amount of heat that is required to increase the temperature of 1 kilogram of a substance by 1 degree Celsius. Is it clear? So that is specific heat capacity. So you can give it as joule per gram per Kelvin, also as, but the SI unit is joule per kilogram per degree Celsius. So when you give it in Kelvin per Kelvin. So I'll explain those things also. So mass standard unit is kilogram, because mostly the questions also will be appearing in that only. And temperature is mostly given in Kelvin. So in that way, when you look, the unit is joule per kilogram per Kelvin. So heat capacity, specific heat capacity. Things are okay, I guess.
The fish world
Yes,
era
teacher.
potilla.
Please unmute yourself. Okay. The next thing is, when you look at the question, same equation you can apply to the question. So Q equals MC delta T. So in this question, tell me what's the mass given here? It's 1 kilogram of water. Already they have mentioned in the question. So unit is important. Sometimes they consider the unit, sometimes they don't. So it's in our side, a safe side, to put the unit. So 1 kilogram. And they have mentioned specific heat capacity of water is 4,200 joule per kilogram per Kelvin. So 4,200 joule per kilogram per Kelvin. And what is the temperature change? Delta T means temperature change. 50 minus 25. The final minus the initial temperature is 25 degrees Celsius. Okay. But remember, the change in temperature is, it's 25 degrees Celsius. You can consider that as 25 Kelvin as well, because the change in temperatures will be the same. Okay. So it's okay if you write as Kelvin also here. Can you calculate this? To get the answer. So simple, only using this equation, you have to answer that. Clear? So same type of question, only will be repeating in the other previous years that you see. So we'll be focusing on that now. See, other thing is, after they ask you these main questions, there are some other sub questions that they'll be asking you. Okay, like some sub questions from other units. Okay, like small questions, like you have to answer generally. Say two properties which a metal used to make the, I'm looking at this question now. State two properties which a metal used to make the heating coil should necessarily have. So this heating coil, we are heating this heater to a very high temperature. So that also needs to have a very high melting point, because that metal should not melt easily. And second thing is, it should resist corrosion. It should not get rusted easily. It should not get corroded easily. So ability to resist corrosion. So these are two answers where you can think logically and answer. Next, last question there. When using this kind of a kettle, using a 3-pin plug is a must. State the reason for it. So these are also general type of questions. So in a 3-pin plug, the third pin is to earth the current. That is to fix it to the ground. When you're studying the electricity lesson, grade 11 book, that time maybe you know about this. So to earth it, the 3-pin plug is important, and also to prevent electric shock. Yeah. So they have asked just a reason. So you can tell any one of that. So is this question clear for everyone?
Yeah.
Yes, teacher.
If there's
Yes,
any
teacher.
doubt, ask me. Okay. Now I'll be moving on to the 2021 question from the same lesson. So this is also just a similar type of question. Same electric kettle. Electric kettle is there, and 1 kilogram of water. Maybe it is using the same formula. You can answer very good. Let's quickly look at that.
Excuse me, madam.
Yeah.
Can I explain the 2000 the early question, please?
Okay, wait. Which question you want me to explain?
The early question, madam.
Early means this last one. Are you asking?
Yeah, the last one and Sorry, the first one.
The last one.
The fourth one and the second one.
Fourth and the second one.
Yeah, madam.
Okay. So I'll explain the second one first. Second one, you're asking this one, no?
Yeah, madam.
Okay. So they are asking you to calculate the amount of heat. So amount of heat, we have to use this equation, Q equals MC delta T. Okay. So they have given you the mass here. The kettle contains 1 kilogram of water. That's the mass. Okay. And in the question, they have given you the specific heat capacity, 4,200 joule per kilogram per degree Celsius. Okay, you can use that. Okay, it's degree Celsius. I've noticed it. I'm sorry. Per degree Celsius into what is the temperature change? 50 minus 25. So delta T is 50 minus 25. It's 25 degrees Celsius. Put that directly. Don't want to write it in Kelvin, okay? Because this unit is given in degrees Celsius. So when you multiply this, you get the answer. And these units are getting cancelled now. So the answer will be in joules. Is it okay?
Okay,
hope
madam.
so.
Okay.
Okay. The last one I'll explain now. This last one, they have mentioned that when you look at this plug, you can see a 3-pin plug is used, not a 2-pin one. They are asking what's the reason for using a 3-pin plug. Okay. So in these 3 pins, one of the,
Madam.
yeah.
Madam, what is it? 200 joule? Second question.
Second question, 200 joule you're asking.
Yeah, what is that? How did 200 come there?
4,200. You're asking about that? This
Uh,
4,200. It's mentioned here. That is a specific heat capacity of water.
okay, thank you.
Okay.
Exactly.
Okay. So the fourth one is they're asking why you need to use a 3-pin plug. So in a 3-pin plug, 3 points are there. In that, one is used to earth the plug. That is used to connect the wire to the ground to prevent unnecessary shocks. Okay. So that is the reason. Is it also okay? Yeah.
Can you please third one?
Third one. Okay. Third one is asking. Here they have used the heating coil now. They are asking you what must be the characters of this heating coil. If you want to use this kettle properly, what are the characteristics that this heating coil must have? Okay. So we know that if it is a kettle, we are heating that to very high temperatures. Then this heating coil is made out of a metal. That metal should not melt. So it needs a high melting point. Okay. And secondly, we know if in a heating kettle, we are using it to heat water. So what happens if this heating coil is corroded easily? The rust particle and all will be mixed with water. Okay, so that's not good. So that this heating coil should be free from corrosion. Okay, so it has to resist corrosion. Okay, so those are the 2 characteristics that this heating coil should have. Any other doubts?
Go, teacher.
Okay, I'll move to the next one. Uh, 2021 paper. See, it's also the same order of the question they are following. Same electric kettle and 1 kilogram of water is used. Okay, shall we answer the first question? What is the amount of heat required to raise the temperature of 1 kilogram of water? So when you have the question paper, just underline these numerical values so that it's easy for you. You all don't want to read it again and again. Okay, from 20 degrees Celsius to 100 degrees Celsius, specific heat capacity is given. So we are going to use the same equation. Q equals mc delta T. So what is the mass? 1 kilogram. Together with me, I'll also continue to do it, okay? 1 kilogram mass. C. What is C here? C is the specific heat capacity. Okay. Then what is that? 4,200 joule per kilogram per degree Celsius. So 4,200 joule per kilogram per degree Celsius. And what is the temperature change? From 20 to 100. So
80. Yes.
yes, it's 80. 80 you can write as degree Celsius. So when you substitute this, what's the answer that you get? 336,000 joules. Okay. Is everyone clear? No doubts in this now?
No, teacher.
This is for the first one. Okay. Now I will move to the second. Look at the second question. Find the amount of heat absorbed by the kettle when the temperature of water. So first question was amount of heat required to raise the temperature of water. So first thing is, first question, they're asking you the heat absorbed by water. Okay. And second question, they're asking you amount of heat absorbed by the kettle. Okay. So we are using the same equation here as well. Same equation. Q equals mc delta T. Now find the amount of heat absorbed by the kettle when the temperature of the water in the kettle was increased from 20 to 100. They have given you the heat capacity of the kettle as well. So remember, did they give the mass of the kettle? No. So mass of the kettle is not given. And also in the question, they have given you the heat capacity of the kettle, not the specific heat capacity. So we know that I have explained you here, heat capacity is only for 1 degree Celsius. We are not considering the mass for heat capacity. Similarly, in the question for the second one, if you want to find the heat absorbed by the kettle, they didn't give you the mass of the kettle. Okay? They just wanted you to find the heat absorbed by the kettle by giving the heat capacity, not the specific. If they mention specific only, you have to multiply with the mass. So there's no specific heat capacity. So just only heat capacity you can use. What's the value? 160 joule per degree Celsius into same temperature change, 20 and 100. Then what's the difference? 100 minus 20, 80 degrees Celsius. So you get the answer, 12,800 joule. Is this clear, everyone? Any doubts?
Yes, teacher.
No, teacher.
Others also, if you have any doubts, please unmute and speak, okay?
Excuse me, ma'am.
Yeah,
Can I explain the first one, please?
first one, okay. First one is, they are asking you the heat absorbed by water. They directly didn't mention heat absorbed by water, but the heat required to raise the temperature of water. So whatever, you're going to use the same equation, mc delta T. Keep this in mind, okay? For all these type of questions, you have to use mostly the same equation. 1 kilogram of water, the mass is already given. Why did I mention 4,200 here? That is a specific heat capacity of water. And then what is the temperature change? 20 to 100? No. So 100 minus 20. So that is what giving you 80 degrees Celsius. You multiply it and you get the answer. Okay, you have marks for units also. So some questions they don't give you marks for units, but mostly they give the marks. So it's better to write. Is it okay?
Okay, teacher. Thank you.
Yes, teacher, fully understood.
Which one? Okay, I'll move to the next one. So first and second is fine. First and second is fine. I hope you all understood the difference between the first and second question also. We'll move to the third one. The power of the heating coil used to heat the kettle is 1000 watt. So the power is not related to this unit. Okay, you have another unit under power section. So from that also you need some knowledge to answer this. Okay, it's very simple, only one equation that you have to use. So power of the heating coil is 100 watt. What is the time taken to heat the water in the kettle from 20 degrees Celsius to 100 degrees Celsius? Okay, let me erase all these. So the question is power of the heating coil. Can you remember this equation? Energy equals power into time. You will meet this equation maybe in another chapter. Okay, this is energy, power, and this is time. Okay, so for this question, you will have to use it. So what are they telling you? The power of the heating coil is 1000 watt. So that heating coil will heat not only water, we know it will heat, the heating coil will heat water and the kettle also. Water and the kettle also. So how much heat was needed for water? We found it earlier from the first question. 336,000 joule. This much heat was needed for water. And for the kettle, this much heat was needed. So from the first question, we got this answer. Okay. So when you're going to use it for this equation, you will be adding these two, sum of this. Okay. So that would be the sum for energy, power into time. So what is the question here? Read the question carefully, third one. The power of the heating coil used to heat the kettle is 1000 watts. What is the time taken to heat the water in the kettle from 20 degrees Celsius to 100 degrees Celsius? They are asking you the time. So just keep in mind the question. They are asking you the time. So let's write the equation. Time equals energy over power. So energy is the sum of these two. This both. What is the power given in the question? This one, 1000 watt. 1000 watt. This is given in joules. I think it's also. So you're going to add this and divide by 1000. You get the answer 348.8 seconds. If you want, you can convert this to minutes, but no additional marks are given, so don't do that. No point of doing it. You can leave the answer here. Is it clear, everyone? Any doubts, please ask me.
No, teacher, fully understood.
Okay. So that's fine. We'll move to the last one. The fourth one.
Madam,
The
please
following
move to the
method.
answer.
Yeah.
Madam, please
What?
move to the, please move to the answer.
Okay. Okay. This is second. Okay, we'll move to the fourth one. The following measures have been taken to prevent the loss of heat from the kettle to the outer environment. So that's some of the measures that we do, that our mothers do at home from the kettle. If they need to heat it, like if they want to keep the heat continuously, what are they going to do? So one measure is closing the lid with the kettle. So we know that. Shall I move the answer?
Okay, madam.
Okay. So we know that heat is transferred using three ways: conduction, convection, and radiation. Okay. So now a kettle, if they are going to close the kettle with the lid, okay, from what type of heat transfer they are going to protect the heat? They are going to preserve the heat. So that's a question here. Okay. So they are going to prevent the heat loss. I'll highlight the question. Prevent the heat loss from the kettle to the outer environment. If they close the kettle with the lid, they are actually going to protect it from convection. So from the convection heat transfer, they will protect the heat. That is, they will not let the heat transfer out. Secondly, they are polishing the outer surface of the kettle. So when the outer surface of the kettle is polished, heat will not go out by radiation. You can protect the heat loss from radiation.
Excuse me, teacher.
Yeah?
I can't see your screen.
So what about others?
Can see, teacher.
Others everyone can see. Or anyone like her?
Can see, teacher.
Can see,
Okay,
teacher.
then. Oh, okay.
Can see, teacher.
You can just leave and join again and see. Maybe it'll be okay.
Okay, miss.
Okay. So when you close the lid, the kettle with the lid, you can protect it from convection heat transfer. Okay, because outer air will not come and mix now when you close it. So from convection heat transfer, you can protect. Secondly, when you polish the outer surface, by radiation, the heat will not move out. So that way you can protect it. So the same type of question, you can see the same type of question is only repeating in both of these years. So as you go on in the 2020 paper, 2019, also you will feel the same. So everyone, shall I move to 2020 paper? Okay. I'll start the next one.
Have you identified that second?
Which one was it? Fourth one?
Yeah, can you explain the fourth one?
Okay. Fourth one is they are telling you they are doing some actions to prevent the heat loss. Okay. So if they close the kettle with the lid, in this three method, from which method you can protect the heat loss? Okay. So if you close it with the lid, actually, the outer air will not come and mix with the water. No. Therefore, you can protect the heat. You can keep the heat itself. You will not let the water cool down. Okay. So that is by convection. That is, if there is no lid, by convection, the heat will transfer quickly. If you close it with the lid, you can prevent the heat transfer by convection. Similarly, polishing the outer surface of the kettle. So radiation means the heat will be used into the surrounding. So from the fire, you get the warmth. That's what radiation I mentioned. So if you polish the outer surface, you can protect the heat loss from radiation. Okay. Any more doubts in those two questions that I have done?
No, dear.
Okay. I move to the.
In Roman number 3, have you identified that second system as a unit?
Can you repeat the question?
Roman number 3, how do you identify second will come as the unit? It may be minutes.
Okay. Your question I can understand. When you consider watt, okay, watt is joules per second. The unit of watt is joules per second. Okay. Therefore, you have the second hidden in it. Did you understand? That's why I have put that second. Okay. Is it clear? Because you know, power is work per second, work per time, work done per unit time. So work divided by time. So the unit of power is actually joule per second, but the SI unit is watt. That's why we write it as W. Okay, the hidden second is there inside the watt. Is it clear? Okay. Now we will move to the next question. This is also a similar type of question. So when you look at this question, this experiment was there. The
Ma'am.
setup was there in your, I can't remember the book text exactly. It was there in a very small chapter. So in that lesson, it is related to chemistry actually. They have joined it here, but not asking the chemistry questions, but just normally like what you can answer easily, they have asked here. Look at the question here. In the apparatus, what measures have been taken to reduce the heat loss? When you look at this, when you read it itself, you can directly understand and identify the answer. See, they have mentioned heat insulated container. So that must be your answer. First one. Did you understand what measures can be taken to reduce the heat loss? They have used a heat insulated container. If they have used a conductor, like now here they have used a styrofoam or something like that material where the heat is insulated. But let's say if a conductor material is used as the cover for that container, then easily the heat will be dissipated and heat loss can. But to prevent the heat loss, they have used a heat insulated container. Is it clear, everyone? Okay. The B part. So they have given a measure to protect from the heat loss. But the second question is, suggest a course of action which can be taken to reduce all the heat loss in these apparatus. You have to reduce more heat loss. How can you do that? You have to prevent more, you have to protect the heat. Some additional steps that you can do. So the thing here is, you can cover it with a lid. You can cover with another insulating lid. Okay, like wood or foam, another insulating lid can be used. That's the first answer for this. Then you also can say this container can be put into another container. Let's say this is this container, the apparatus that's given in the paper. You can keep that inside another insulating container. So more heat will be protected. This is the second answer. So first answer is, I'm telling the answer, if you need, you can write it. Using insulating lid such as wood or foam. And secondly, inserting this container into another container, another insulating container. Is everyone okay with both of these questions?
Yes, ma'am.
Yes.
Okay.
Excuse me,
So,
ma'am.
yeah.
Lagging.
Yes,
Okay, can you repeat it?
Your voice is a little bit lagging.
Is it so? I don't know what's the problem. What about, how is it now? Is it the same?
Yes, ma'am.
Okay. No. Give me a minute. How is it now? Is it the same?
Now
Is it
fine,
the
teacher.
same? Now is it fine or the same?
Fine, teacher.
Now
Okay.
it's okay.
Okay. Thank you for informing me. If there's anything like that, quickly tell me, okay?
Madam, can you tell for the A?
Yeah. Which one? For the A part?
Both one A and B.
Okay, I'll explain again. Now the A is in the apparatus, what measure has been taken? So the difference in these two questions are, first they are asking you, what is the steps that's already taken? Already they have done it. What is that? And second question, if you want to protect it from more heat loss, what are you going to do? What can you do? Some more steps, additional steps. So already what is done? They have used a heat insulated container. This is like made out of Regiform or something. So they have used a heat insulated container. And secondly, what's the question they're asking? More additional steps that you can do to protect it from the heat loss. So that's what I told you. You can use an insulating lid. So B, you can use an insulating lid. Or else, another step they're asking, you can insert that vessel into another container like this. This vessel, you can insert into another container with water or without water. Anyhow, just we can mention inserting that or heating that. But
Insulating.
insulating means it will not allow the heat to pass. Conducting means it will allow the heat to pass. Let's say you're pouring hot water inside a Regiform cup. Regiform cup. Okay. And let's say this is a metal cup. In this cup, quickly the heat will come out. Okay, in a metal cup, quickly the heat will come out. But in the Regiform cup, you can't observe such heat coming out. Okay, heat will not come out. Therefore, this Regiform cup you call as insulating container. Did you understand?
Teacher, we can use porcelain cups, right?
Yeah, porcelain cups are also insulating material. But actually, in your books, usually in the science, when we study that, styrofoam cups, okay, styrofoam, Regiform, these material they usually mention other than porcelain. Okay, when you when the things come, give priority to these materials first. So, any more doubts in these two questions?
No.
No, teacher.
How is my voice? Is it okay or still lagging or something?
Madam, can't
No, no.
explain the heat lesson is madam.
What?
Madam, can't explain the heat lesson, the full part.
The full. Okay, if you want, I can put another session to explain it. Okay, after this session ends, give me a message. Then, if you want, we can put another session for that. Okay.
Okay, madam.
Okay. This time, if you want, you can tell us. We'll do an extra session for that.
Madam, then when can we do?
I'll tell about that. Okay.
Okay.
I'll tell about that for sure. Inshallah. By the end of this session, I'll tell it to you. First, we'll discuss these entire questions. Okay. So, shall I move to this fourth question?
Okay, miss.
Miss.
You read the question carefully. I told you if there's anything important, you can underline it. So I'll be highlighting it now. 50 centimeter cube of each acid A and B of equal concentration is taken. So in a cup, in a container, they are taking 50 centimeter cube of acid and 50 centimeter cube of base. Altogether, then what's the volume? 100 milliliter. Centimeter cube means milliliter. Okay, I'll write as centimeter cube. 100 centimeter cube is the total volume now. The temperature change occurred here was 10 degrees Celsius. So already they have given you temperature change is 10 degrees Celsius. So what is the first question? A very simple question, this one. What are the readings that should be taken to determine the above temperature change? How are we determining the temperature change? It is the initial temperature. I'll write a stem. Initial temperature of the reactants. Okay, initial temperature of the reactants. And what is the other one? Initial and the
Final.
final. But there's a thing here. Final temperature of the mixture. But the problem is when I was looking at the marking scheme, they have mentioned that when you have written final temperature, marks is not given. Instead of that, they wanted you to write as maximum temperature. Because let's say when you mix it and when the reaction is proceeding, it will reach to a maximum temperature. And after that, the temperature can come down. Okay. Therefore, it's better to write as maximum temperature. Okay. Now we look at the B part. Calculate the heat change. So same type of question that we saw earlier. Heat change, heat absorbed. Yeah, it can be of different type also. See here it is mentioned as heat change. Here it is given as amount of heat absorbed. Amount of heat required to raise the temperature. Same question, but they have asked you in different words. Calculate the amount of heat. Okay. So for all of these, you will need to use the same equation. What is that? Q equals mc delta T. Okay. So you have to calculate it.
Anna, excuse me, Anna.
Yeah.
If you don't mind, can you explain from first?
Okay. You want me to explain from the fourth question, fourth Roman number 4?
Yeah, Anna, from Anna.
Oh, okay. So the thing here is they're going to react an acid and a base. So for this container, they will put acid and they will put base. Okay. 50 centimeter cube of acid, 50 centimeter cube of base. Altogether, this will be the volume, 100 centimeter cube. Okay. Now the thing is, the question is, before that they also have mentioned that they have obtained a temperature change of 10 degrees Celsius. Temperature change. That means you have to get the two temperature. Temperature of the first one, the starting, and the last. So we know that as you're told now, we find the initial temperature of the reactants and the final temperature. But in the marking scheme, I said you, final temperature for that marks is not given. Instead, you will have to write there as maximum temperature. Because let's say the temperature of initial is 20. This is the starting temperature. I'm just telling you, okay? Little by little, the temperature has reached to the finally maximum 80. But later, it can reduce to 75 or something like that now. Therefore, we take the maximum temperature, not the final. Okay, is it clear?
Yes, ma'am.
Okay, I'll move to the B part then. So calculate the heat change they're asking. As mentioned earlier in the other questions like they have asked you what is the amount of heat absorbed? What is the heat required to raise the temperature? So all of these are the same question, but in different words they have asked you. So the same equation you are using, Q equals mc delta T. So here also, mass, then specific heat capacity, and the temperature you need to know. Let's see. What is the mass here? Have they given you the mass? No, they didn't give you the mass, but they have given something as density. And we also know the volume. So density here is 1 gram per centimeter cube. And the volume is, what is the volume? I mentioned already, it is 100 centimeter cube. And what is the equation? In chemistry side, you learn it. Density equals mass divided by volume. You need to find mass. Okay. Then mass equal density into volume. 100 centimeter cube, you are going to multiply by 1 gram per centimeter cube. So what will be the mass? 100 grams. That's it. Okay. Now, when you look at the specific heat capacity,
They have to change.
look at yeah,
They have to change now.
yeah, that's it. Now, see, it is given in kilograms. So what are you going to do? You have to change your 100 grams into kilograms. So 100 grams. If you want to change it to kilograms, you have to divide it by 1000. These are simple ones. So the unit is kilogram. What is the specific heat capacity given? 5,000. 5,000 joules per kilogram per degree Celsius. And then what is the temperature change? It's already given at the starting of the question, 10 degrees Celsius. Yeah. So you can directly get the answer. So your answer would be 500. See, in this, these are getting cancelled. You get only joules remaining. Is it clear, everyone?
Yes, teacher.
Any doubts? Yeah, okay. So the next question, this is a chemistry part. I'll just quickly discuss that. Sketch energy level diagram. Okay, this is the energy level diagram. You have to draw something like this. This exercise is not needed actually. So here in this axis, you'll be
Yeah.
writing. Yeah.
For the fourth one, it's coming 500 or 5,000.
1,000, right?
Is it 5,000? I'm sorry. Okay. Now, okay, now?
Okay.
Okay. Sorry for that. So your energy level diagram, they're asking you to sketch. So when you draw, this axis is important. So you have to write as energy. And that energy will be giving in, you can just write as joule per mole, or else more standard specifically is kilojoule per mole. So at your level, these reasons why we are using it is not needed. Okay, if they ask you to draw the energy level diagram, write energy and write this as the unit. Now tell me in this, what is happening? Heat is coming out or heat is taken inside? What happens? Will finally will it be hot or cold? Finally, the cup that we are using here will become hot. That means what? Finally, temperature is high. Okay. When the final temperature is high, the product has listen to this again. Finally, the temperature is high. That means what? Heat is liberated. Heat is liberated. Heat means that is energy. So that you can understand that the reactant is having high energy. The reactant is giving energy out in the form of heat, and that becomes the product finally. So remember, they are giving out heat now. So when they give out heat, the reactant is having high energy that would give off heat. Okay, you can just see, understand here, they give off heat. Don't need to mention this and all. Heat is given off and coming to product which has low energy. So this is how you need to draw the energy level diagram. Anyone having doubts in this?
No, miss.
Okay. Now I think I can move to 2019. This is also very simple as we have done earlier the same equation, but see each and every time the type of question, how they ask you the question is different, but the theory is the same, the simple one. Okay. See, A and B are two identical vessels of negligibly small thermal capacity. So in this question that we discussed, can you see they have given the heat capacity of the kettle also. That time we have to find for the kettle. But here they have said you that for the container there's no heat capacity. So in your question you have to consider only water and the liquid. So the same picture they have described you. A vessel contains. So when you have a picture and the thing here, you can compare both and read. And if you want to note down anything, quickly note it down. Okay. Now see. Vessel A contains 2 kilograms of water. It's mentioned there of specific heat capacity. So you can write C equals 4,200 joules per kilogram per degree Celsius. These units are not needed. Just write as C equals 4,200. Here also there's 2 kilograms of liquid X. Here what is the C? 2,100. So for both, we are supplying this amount of heat. So what is the Q? 8,400 joules. I hope this is clear. Now read the first question. What are they asking you to calculate? Calculate how much will be the increase in temperature of water. Increase in temperature of water contained in vessel A when supplied with the above amount of heat. So increase in temperature of water means what is that? So you have this equation Q equals mc delta T. The same equation that we had followed in the previous questions. What is the mass of water? 2 kilograms. It's there. What is the specific heat capacity of water? 4,200 joule per kilogram per degree Celsius. Change in temperature or increase in the temperature of water. That is the change they are asking you. That is what you need to find now. And Q is 8,400. Now, it is very, very simple for you to get this answer. Okay. So you get the answer as 1 degree Celsius. Okay, everyone. Any doubts in this?
Ma'am,
Yeah.
can you please explain the previous question?
The previous means 2020 asking.
Yeah,
Okay, which one?
last one.
Last. Okay, I'll explain it quickly. Calculate the heat change associated with the above reaction. What is the thing? Same heat change they're asking you. I have erased it now. Okay, the same heat change they're asking Q equals mc delta T. But mass is not given. But we know an equation to find mass. Density equal mass over volume. With that you can get mass equals density into volume. So what? We have the density 1 gram per centimeter cube. We have the volume 100 centimeter cube. So mass is 100 grams. But are we using grams directly? No. we have to convert the grams to kilograms. So 100 you are going to divide by 1000 kilograms, and this one you can use in this equation. Is it clear? When you try this again, it will be okay for you. The one who asked the question, is it okay?
Madam, which answer is this?
She's asking me to explain 2020 last one.
Sixth one.
Yeah. The one who asked the question, is it okay? Okay, I'll move on to the question that I was discussing. This is for the BPA 2019 first question. Everyone, is it clear? Or any explanations needed in this question?
We
Okay,
understood.
then I'll move to the second one. This one, okay, second I'm discussing. It is also the same question. They are asking for liquid X in the vessel B. For this one, they are asking. Same question again. Increase in temperature of the liquid X. So what are you going to do? The same equation. This is for the first one. For second one, Q equals MC delta T. What is the Q? Same Q only you are giving, same heat. Q means heat. That is, you can provide it with a Bunsen burner or something else they are giving it. Okay. So same 8,400 joule is given for this one and for this one as well. So 8,400 joules. Mass is already given. No, it's so simple. What is that? 2 kilograms. What is the C of this? 2,100 joule per kilogram per degree Celsius. And you need to find the temperature. So when you solve all this, delta T is 2 degrees Celsius. So students, is this both okay?
Yes, ma'am.
Yes. So based on this, they will ask you another question. They're telling you which of the above liquid is more suitable to be used as a cooling agent. So which is suitable to be used as a cooling agent? That is the question now. Now tell me, cooling agent means what? You have to, like, when you heat it, it has to take more time to get heated. Okay, that is what meant as cooling agent. Like, let's say, when you heat this, let's say the two liquids I'm taking here, the liquid A here, that is water we have used. You are going to provide heat for this A. They have used water. And here you have used a liquid X. Here also you are providing the same heat. So when you provide the same heat for the same period of time, this has increased only 1 degree Celsius. Same heat, same time. Increased only 1 degree Celsius. But this has increased 2 degrees Celsius. That means what? This one becomes hotter quickly. This one takes time to heat. So if it is taking time to heat, then you can say that is a good cooling agent. If it is taking more time to heat, then that is a good cooling agent. Okay. Now read the question here. Which of the above, this question, okay? Which of the liquid is more suitable to be used as a cooling agent? So which one? Water. Because you can say that the rise in temperature is less. Or else, what's the other thing that you can say? Water has a greater specific heat capacity. See, specific heat capacity of water is 4,200. So it is having a greater specific heat capacity than the liquid X. Therefore, a good cooling agent can be considered as water when you compare with that of X. Did you understand the question that I have explained now? The third one.
Excuse me, teacher. Can you please explain it a bit?
Okay,
Again.
I'll explain it again. Now they are asking in these two liquids, in water and liquid X. Look at this, what I have drawn here. In the water and liquid X, which one is a good cooling agent? Which one is a good cooling agent? Is it water or is it X? First, what is a cooling agent? Cooling agent means when you give the heat, the temperature rise must be less. Little amount only the temperature rise must be. So that when you give the same heat for water and same heat for this X will heat very quickly. Very quickly it gets heated. But water, it takes time to heat. It's getting heated very slowly. So that is why we say water is a good cooling agent. In other words, what is the C of water? 4,200 now. C of this liquid is 2,100. What is meant as specific heat capacity? Amount of heat required to raise the temperature. Okay. So if you want to rise the temperature of X, you have to give only little amount of heat. That means with little heat itself, it is getting heated too much. And if you want to heat water, you have to provide large amount of heat. Then only it is getting heated. In other words, you can tell that answer. So when you get as the answer for this, the most suitable one is water, because the rise in temperature is less. You can see, 1 degree Celsius for water. For the other one, 2 degrees Celsius. So rise in temperature is less for water. Hope you're clear. Some more explanations needed for this question?
Why
Yes,
we
teacher.
why we telling that the heat capacity is high? Water. The
What's the comment? Can you repeat
4,200.
that? Can you tell me again? What did you say? Yeah, tell me what you were saying. Any more doubts in this? You want me to clear some more?
Yes.
Okay. Again, read the question. They are asking you which one you can use as a good cooling agent. Cooling agent means it has to cool only. Like heating must be less. So in this too, when you give the same heat, this liquid is heating to 2 degrees Celsius and water is getting heated to 1 degree Celsius only. So which one is getting heated less? Water getting heated less. If it is getting less heated, then that is the cooling agent. Simply you can answer in that way. I hope you all are clear.
Yes.
Okay. Now we'll move to the last question over there. Look at this graph. So this shows the state of matter. So what are the 3 states of matter?
Solid,
We have solid, liquid, and gas. Now let's explain from the graph. Solid becoming liquid, you call as melting. Solid becoming liquid is melting. Liquid becoming gas is called as vaporization. Okay. The reverse process gas becoming liquid is condensation. Condensation. And liquid becoming solid is freezing. Are you all okay with these words?
Yes, teacher.
Yeah.
Yes.
Now, when you focus that with the temperature, now solid becoming liquid at 0 degrees Celsius only. That means solid becomes liquid at the freezing point. Liquid becomes solid at melting point. Understood? So freezing point and melting point is this 0 degrees Celsius. The solid becoming liquid and liquid becoming solid happens at the 0 degrees Celsius. That is the freezing point and the melting point. Similarly, we have the other thing as boiling point. Boiling point, that is where the liquid becomes a gas. That is 100 degrees Celsius. So that is also simple, nothing to worry there. Now remember, we'll answer the question. While answering, we'll explain the others. A thermometer was introduced into a vessel. Later, when the vessel was heated continuously, the thermometer reading stopped rising further after the water reached a certain temperature. Okay. They have mentioned that thermometer reading stopped rising further. What do you mean by that? Thermometer reading stopped rising further means what? Did the temperature change? No. So there is no temperature change. No temperature change. Okay. Thermometer stopped rising further means there is no temperature change. Okay. Temperature is fixed. Can you see? This one, it is waiting in that same temperature. Here, it is also waiting in that same temperature. But heat is given. This much amount of heat is taken. But did the temperature change? No. So what happens here is that the moment solid is getting converted to liquid, heat is getting added. Heat is absorbed. You're providing more and more heat. But you cannot observe any temperature change. So that heat absorbed here is called as latent heat. That heat absorbed is called as latent heat. Okay. So here's the question they're asking when you read it carefully. So you can see here that latent heat means, okay, the heat absorbed by the system without changing the temperature. Heat is absorbed, but temperature is not changing, but change of state is taking place. Solid becomes a liquid that time, but heat is absorbed. That heat is only you're calling as latent heat. Okay. So we have latent heat of fusion and latent heat of vaporization. So this place is where the solid is getting converted to liquid is latent heat of fusion.
Teacher, what
And
is
where the
latent heat?
yeah, the latent heat means you can see now here heat is given. Heat means the fire that we give, or else let's say the amount of, or let's say when you're heating it with the Bunsen burner, you're providing the heat continuously. That is heat added. Okay. So you're giving the heat, but will the temperature change? No. Temperature is at 0 at this moment. But heat is given. That heat only you're telling us latent heat. When the temperature, even though the heat is given, no temperature change, but the change of state is taking place. It is getting converted from solid to liquid. Okay, I'll explain it further. Latent heat, you have two types. First is latent heat of fusion, and the other is latent heat of vaporization. Okay, so latent heat of fusion means, you can see, as I already told you, at 0 degrees Celsius only, solid gets converted to liquid. Okay, at 0 degrees Celsius. But at all these points, the temperature is at 0 only. No temperature change happening. No temperature change. But change of state of matter happens. That time, we are giving the heat continuously. Let's say from the fire or something else, we continuously give the heat. The system or the reaction is absorbing the heat. That heat absorbed is the latent. So here it's latent heat of fusion, and here it's latent heat of vaporization. Now, when you look at the question, maybe you'll get okay with that. So when you put this is liquid now, this is water, and you're continuously heating that. Look at the picture that I'm drawing. And you're keeping a thermometer inside. At a certain point, the thermometer reading stopped rising further. Thermometer stopped rising further. That means what? There is no temperature change. So for a liquid, this is a liquid. This point and this point, you just have to keep in mind. Little by little, I'm giving more and more heat. This fire is giving more heat. So I'm increasing the temperature. But at a certain point, no change in temperature. The thermometer reading has stopped. No change in temperature. That means, what can you say? The liquid is getting converted to gas when there's no temperature change at that point. Okay. So first A part, by what name is that constant temperature known? How do you call that constant temperature? By what name? It is the boiling. Okay. At that instance, what is observed in the water? This is a logical question. During the boiling point, when you look at the water, what can you see? Bubbles coming off. Bubbles. Also, you can see steam coming also, you can see. But more than the steam, bubbles are more suitable. Okay, we'll write it. Bubbles coming. And then, what is the change of state occurring at that instance? Liquid to gas. So, liquid converting to gas. Next, what is the name of the heat absorbed at that instance? I mentioned you what's the name of the heat? Latent heat of vaporization. When liquid is getting converted to gas, there's no change in the temperature, but some amount of heat is absorbed. So that heat is latent heat of vaporization. The spelling is there now, you can look at that. Next, state the reason. Okay, before I go to the last question, until this, is it clear?
Yes, teacher.
Yes, teacher.
Yes, teacher.
Okay. Now see, why are they absorbing the heat? So this is solid particles, tightly packed. Solid has to be converted to liquid so that they will have a gap between the particles. This is solid, this is liquid. So latent heat is used to, so during fusion, this latent heat of fusion is used to, see this is latent heat of fusion. This is used to break the bond. Okay, they would break the bond in the solid and give off the atom. Break the bonds between the atom and let it be free. Similarly, when you consider the gas, even more space would be there. So latent heat of vaporization is used to break the bond between the liquids. So what must be the answer for this question? State the reason why temperature of the liquid stopped rising, though the heat was supplied continuously. The heat supplied is used to break the bonds. Break the bonds between the atoms. Okay, so once again, I'll quickly summarize this graph. Let's say I'm increasing the temperature. It was a minus value, let's say it was -5, let's say, just for example. I'm increasing the temperature little by little. And when it reaches this point 0 degrees Celsius, solid will be converted to liquid. But for some time, no change in the temperature, but heat is absorbed. That heat is used to break down the solid, the particles, the bond between the solid particles into liquid. They break the bond and convert the solid to liquid. And after all the bonds are broken down, and after the entire solid is converted into liquid, again the temperature will rise again from 0 to 10, 20, again it will reach 100 after that. After it reaches 100, again there's no change in the temperature. And then that time liquid will be converted to gas. And after all the liquid is converted to gas, finally, again you can see the temperature would rise from 100 to 150, whatever. If you keep on increasing, the temperature would increase further. So this is the summary of this lesson, this part. Hope you all understood. Is it clear, everyone?
Yes, teacher.
Teacher,
Yeah.
what is the difference between thermal equilibrium and latent heat?
Okay. Thermal equilibrium is a separate word. There's no relation to thermal equilibrium and latent heat. Thermal equilibrium means, I'll write it this way. Let's say you have a hot object here, 100 degrees Celsius, and this object is 20 degrees Celsius. Now you're going to keep these both objects together. Then what happens is, heat from this object will move to this one. Okay, heat from this object will move to this. And finally, both of them will be in the same temperature. Finally, both of them will have the same temperature. Let's say 60, this would have 60, this also would have 60. Then we are telling that both these objects are in thermal equilibrium. That is thermal equilibrium. And latent heat is this. Understood?
Yes, teacher.
Okay. And another
What is
one, yeah.
Vaporization and evaporation.
Vaporization and evaporation. Asking the difference.
Yes.
Is that so? What you are asking? Can you repeat your question? I didn't hear it properly.
Difference between the vaporization and the evaporation.
Okay, I'll tell you it. Let's put a chart. The difference between vaporization and evaporation. Then together with that, I'll explain. I'll erase all this. Vaporization, evaporation. So conversion of liquid to gas, liquid getting converted to gas is vaporization. Evaporation is also the same thing, but vaporization happens at the boiling point. That means that for vaporization, you have to give 100 degrees Celsius. Okay. Evaporation is also the same. Where you convert the liquid to gas, but it can occur at a temperature less than 100 degrees Celsius. 100 degrees Celsius is not a must for evaporation. That is the thing. Let's say in a table you're putting some water, and after some time when you come and see, there's no water in the table. So that is coming under evaporation. It happens at a temperature less than 100. But when you boil it in a kettle, if you keep water and that water getting converted to steam, then that is vaporization. Okay with the difference? Okay. So that is the heat lesson. So I hope you can answer all these questions. And when one of the questions from this lesson appear in your paper, it's simple because you have to use one and only equation. Q equals mc delta T. The same equation they're asking in different forms. So if you have, you can do some more questions like in model papers, some more questions, and the past paper question beyond 2018, you can find questions like this. So you can do it, and if you have any doubts, you can ask me. Okay, I'll give my number at last. You can ask me. I'll explain it later. Okay. Shall I move to the next part?
Okay, teacher.
Okay. Actually, I thought of discussing this lesson, that is your in your grade 10, first grade 10, part 1, and you have all these units. So all these units come in a combination for a question. So questions come as a combination with all these units. So I thought of discussing that. And then the optics. Optics also have question from 2022 to 2018 because that is the new syllabus. So until that, because after 2018, 2017 and all comes after the all syllabus papers. So optics question is like appearing everywhere. So there's a chance for you also to have it. So that's why I have selected that unit also. But seems like there's no time. We have just half an hour left. So I'll try to complete maximum. If you all want another session, I can put it later. Okay. Now, to the next one. These are very simple ones actually, because this appear in your grade 10 first part. You might have studied it many times. So it is easy. You can quickly score in that. We'll go soon. So shall I begin? Let's move. So when you look at this diagrams, you can see that if you consider in a table, the weight of the object is coming down. You have the perpendicular force acting upwards. Tell me what is the relationship between this weight and R? Weight and R, the reaction force and the weight is equal. Similarly, if you consider an elastic or else a string or a rope or something where you tie an object, that object would have a tension force. That tension force will also be equal to weight, according to this picture. The next thing is, look at this swing. When you look at the swing, this boy's weight is acting downwards and two ropes are tied on either side of the swing. So you have to understand that this F1 and F2, the sum of them will be equal to weight. Okay, F1 plus F2 will be equal to weight. And both of them will be in opposite direction to that of the weight. But in this, can you say F1 plus F2 equal to W? Can you say something like this? No, you can't say so. Okay. Here the thing is, you have to get the resultant of this. Let's say if this is F1, if this is F2, you have to get the resultant of F1 and F2, which would be facing in this side, this direction. then that resultant only will be equal to, so resultant of F1 and F2, resultant, there's a method to find it. It's coming under the A-level lessons, so now y'all don't need how to find the resultant and all. But just keep in mind, resultant means this and this together. This and this together, resultant. So resultant is only equal to weight. Okay. So in this full picture, is there any doubts?
No, teacher.
Okay. Now we'll focus on the question. So in this picture, they are asking you to mark the tension and the weight of the rod. Mark the T1 and T2 and the weight. So this is T1, very simple. T2, you can change it also, it's not a problem. And the weight. So what is the relationship between T1 and T2? It is the same string, no? So same string means same string. Tension will be the same. So what is the relationship? T1 and T2 will be equal. Then as I have told earlier, T1 plus T2 equals to W. That is also clear. Next, mass of the person is 200 grams. How are you going to convert the mass to weight? Okay. When you want to convert the mass to weight, we know F equals to MA. F is the weight. Okay. F is the weight. Weight equals to MA. And actually, it's not the A. What is the A? They are mg. 10. Okay. So we need to find the weight. The mass is 200 grams, but you have to write that in kilograms. So 200, you have to divide by 1000 if you want to write it in kilograms into 10. So you can cut off. So what is the weight? Weight is 2 newtons. If the weight is 2 newton, T1 plus T2, T1 plus T2 equals to 2 newton. T1 and T2 equal. So T1 will be 1 newton, T2 will be 1 newton. Hope this question is no doubts, no? If there are any doubts, please ask me now itself.
No, teacher, no doubts.
Okay. Now move to this question. Question from 2021. Okay. Now this type of question is going to read itself. If there's anything to mark, just mark it down. ABCD is a horizontal path. The distances between the points AB and BC are equal. So these are equal. You can just show it this way. These are equal. The paths of the paths AB and CD offer friction. AB and CD offer friction. So you can mark it there. Here friction. This is also giving friction. The part BC is smooth. So this is smooth. A trolley of mass 4 kilogram. Just highlight this and keep. 4 kilogram was placed at A and a horizontal force of 12 Newton was applied. It is already marked, so it's okay. When the trolley reached B, the 12 Newton force was removed. So at this point, the 12 Newton was removed. So here there's no friction and there's no 12 Newton force also. Then what happens? From C, it finally came to rest. Okay. Now we are asking us to describe the path from A to B, from B to C, and then from C to D. Okay. So A to B, it is going with a force, that is an external force, unbalanced force acting. So then you can directly say it's acceleration. They have given that also. Here what? Is there any unbalanced force? No unbalanced force. The 12 Newton force is also removed. There's no friction in B to C. Unbalanced, there's no unbalanced force. No unbalanced force. There's no friction also. Passage is smooth. So it is moving with constant velocity. And then what they have mentioned from C to D, it's already in motion we move. From C to D, it comes to rest. So coming to rest means deceleration. Okay, how can you draw this in a graph?
Instead of constant velocity,
Yeah.
we can use uniform velocity. No?
What did you ask?
Instead of constant velocity, can we use
Yeah.
uniform velocity?
Yeah, uniform is also the same. Constant. Uniform, both are having the same meaning. Okay, this graph is a simple
Ma'am, is
one.
it wrong if we write only velocity?
Yeah, it's wrong if you write only velocity because velocity can change. In this acceleration, that is changing velocity. So if you write only velocity here, it's anyway wrong. They're not giving you marks. Okay, you have to mention there as constant or uniform.
Thank you,
Okay.
madam.
Okay. Now the thing is, they have asked you to draw the graph. They have given the axis also velocity time, acceleration, constant velocity, deceleration. So it is very simple. There's no marks like numerical values for you to put. So you can just draw. This is acceleration. This is constant velocity. This is deceleration. You have to draw it properly. This is deceleration. No need to see the gradient and draw nothing. You can just roughly. Okay. Let's look at the third one. What is the unbalanced force acting on the trolley in its motion from A to B? See the A1. A to B, this side it is 12. This side it is 4. So what must be the unbalanced force acting there?
8 Newton.
Yeah, 12 minus 4, 8 Newton. It's better to write as 12 Newton minus 4 Newton, 8 Newton. Okay. So unbalanced force is 8. So next question you see, they're asking you to find the acceleration. We have the force. Yeah.
Unbalanced force means the resultant, no?
Yeah, resultant. Unbalanced and resultant gives the same meaning. Okay. Now we have the force and we also have the mass. The mass of the vehicle is also there. What are they asking us? Acceleration. So easily, what's the equation? F equals ma. So you can find the acceleration of force divided by the mass. Force is 8 Newton divided by 4 kilogram. So 2 ms minus 2. Units are very, very important. You have to write that also. Is it clear, everyone?
Yes, teacher.
Okay. Now we will move to the next one. So look at this. They have given a fan balance, a sugar, and a weight is mentioned. When 1 kilogram of sugar is placed on one pan of the balance, what is the weight that should be balanced on the part? That is, here if you keep 1 kilogram of sugar, here what is the weight you have to keep? The same 1 kilogram so that it is balanced. So your answer is very, very simple. Even a small child could answer that. It's 1 kilogram. Next, what is the force acting on the string by which the balance is suspended when it is counterpoised as mentioned in the first one? The mass of the balance is 3 kilogram. Okay. So what are they asking you here? Force acting on the string. Let's say here the mass is there, which is 3 kilogram. Okay. what is the force acting on the string by which the balance is suspended when it is counterpoised as mentioned in the first one. So something like this, they are balancing it. Okay. This is nothing actually. You're counterpoising in this way. What is the force acting on the string? So how are you going to answer this? The mass of the balance is only 3 kilograms. So this one is something like this. Now here 1 kilogram weight. This is also 1 kilogram weight. Okay. Then now this is 1 kilogram, 1 kilogram. If this is 1 kilogram, what would be this tension?
1 kilo.
Yeah. It's also the same thing. Now 1 kilogram means it's 10 Newton. 10 Newton, 10 Newton. This also would be 10 Newton, 10 Newton. So with this, we have this, and here is the string. Okay. Here is the string. They are asking the tension of this string. Okay. So this is together 10, 10, 20. And what is it? The mass of the balance is 3 kilograms. So 20 plus, the balance would give another 30 Newton from this. That would also getting added to this. 30 Newton would give you 50 Newton. Is it clear? How did this come? Because of this 1 kilogram, here there is a 10 Newton. Because of this, there's another 10 Newton. Mass of the balance is 3 kilograms. That is 30 Newton. So altogether, it would give us 50 Newton.
Yes, teacher.
Okay, I'll move to the next one.
Ma'am, can't we use F equals MA?
So which one are you asking for this tension question that I was explaining?
Yes, madam.
No, because acceleration is not related to this. Acceleration comes when something is in motion, when something is moving. Okay, so for this, you have to put individually, you have to see, you have to calculate and so you have to draw the diagram and just see. Here there's 30 Newton. Because of this weight, we have to take the string as 1. Because of this weight, there is another. Okay, and that together would give the tension of this string. Did you understand?
Madam, they have given the gravitational acceleration value to convert kilograms into Newton.
Yeah, that's it. The 1 kilogram, you have to convert to Newton. That's why they have given this 10. You have to multiply 1 by 10 and get it. So don't confuse this with MA and all, okay?
Yeah, but I did it with MA, but still got 50, madam.
Oh, I didn't get it, but they're telling.
I used that equation and did the
right.
question, but
Yeah, you
still
can
I got 50 Newtons.
I mean, you got the same answer as mine or something different?
No, the same answer.
Yeah, same answer. But they won't give marks for converting kilogram to and all because the question is focusing on something else now. So you can directly write as 1 kilogram equal 10 Newton. If you want, you can convert. You can write as F equal M and do it. But directly when you write like this also, it's okay. Because main part of the question is not this.
Okay, thank you, madam.
Okay. Shall I move to the next part? So here, they're talking about moment. So moment means when something is rotating, a moment is created. Okay, rotating around an axis, a pivot point must be there. something is fixed and it's getting rotated. Then a moment is created. Okay. So you have the force acting down. Here there is a distance. So they can ask you, let's say I'm writing this as point O. Calculate the moment around point O. Then the moment equals force into distance. And let's say if there is another person sitting here, then there's another moment created like this. So this side, it would rotate like this. That is a clockwise. Here, it would rotate in the, sorry, this is the anti-clockwise. If it's rotating like this, anti-clockwise. So this side, when it's rotating this way, you have the clockwise. So what is the relationship between the clockwise and anti-clockwise moment? Both of them are equal. So clockwise moment equal anti-clockwise moment. So using that also, there are some questions from the solve. So when you look at this, the same diagram they are explaining in this paragraph. Read the A part. Find the moment created around point O by a mass of 50. Point O is this. Around point O by this 50 kilogram. What is the moment created? Moment equals F into D. What is the force? You have to mention it's not 50 kilogram, then 50 into 10 Newton. If you write it this way, it's fine. 50 kilogram into 10 meter second minus 2, which would give you this. And don't want to convert to meter. You can directly write as centimeter, and 50 into 10, or if you convert to meter, it's fine. It's better to convert to meter, but you can directly write this way. Also, yeah, so sometimes they expect it, but if you write it this way, it's also fine. But safe to go in meters. We'll write in meters. So 5 centimeter, how are you going to convert to meter? Divided by 100. So you get the answer 25 Newton meter. It's better to write in Newton meter itself. So if we have centimeter, convert it to meters. Better to be on the safe side. Okay.
Teacher.
Yeah.
How did you get the 10 Newton?
Okay, 10 Newton is 50 kilogram now. 50 kilogram, you have to convert to newtons. That is, mass you have to multiply by G. What is G? 10. That's why I have directly multiplied like this. Mass into gravitational acceleration. Understood? 50 kilogram will give you 500 Newton. Yes. Okay. Then they ask you an expression in terms of M for the moment created around point O by the weight. Expression in terms of M. Around point O in terms of M, 100 into M. So, we know moment equals force into distance. Force is M. M is weight now. So, you can directly write as M. G. Okay, that is giving you the weight into 100 centimeter, or else 100 centimeter equals to how many meters? 1 meter. So you can write as mg. This is fine. Okay.
Why, madam, mg? M, no? Wait.
M is actually, they have given the mass of this. Okay. So if you want to convert that into the acceleration, if you want to convert that into the weight, you multiply with the gravitational acceleration and write it. Okay.
Okay.
And
Ma'am,
as
if we
this,
write 10M,
yes.
if we write 10M,
Oh, that's also fine. It's not wrong. 10M is also correct. Okay. Now what is the next thing? When the balance is counterpoised around the point O, anticlockwise moment created by the 50 kilogram mass, that means they are talking about this one. 50 kilogram mass, this is the anti-clockwise moment, this one. And the clockwise moment created by the weight, this 10 m, are equal. Then you have to find the value of m. Then
They're talking
10
about the equilibrium, no?
But very good. What did you say? Can you repeat it again? Can you hear it properly?
Equilibrium, no?
Yeah, they are equilibrium. So what I want to say, 10 m equals 2 Newton meter. This is a unit. Actually, don't confuse the mass and this Newton meter. So it's better to just write like this. So m is equal to 10 divided by 2, 5. It's coming in kilograms. Oh, kilograms or Newton is it coming? Tell me. Here it's kilogram because we have already written it as 10. Is it clear, everyone, why I have directly got the answer as 5 kilograms?
Yes, teacher.
Okay. So the next question is it clear? Any doubts? I can clear it out soon.
Madam, isn't it 2 divided by 10?
I'm sorry. I'm so sorry. It's 2 divided by 10. So sorry, okay. So it has to be 0.2 kilogram. Can you say for that?
Madam,
Okay, the
M,
last
M
question.
mass, no?
Yeah, M is mass.
Madam, for A, was it 25 or 2?
J,
25, no?
it's 25. No, again, I made a mistake. Really sorry. Okay, I'll repeat the question again. Sorry, you can notice that. Really sorry. It's 25 Newton meter. So this also would be 25 divided by 10, 2.5 kilogram. Now it's fine, no?
Yes.
Yes. So next thing is they're asking you the difference, why a flow balance is more advantageous when comparing that with a pan balance. Flow balance and a pan balance. So I took pictures of that, but okay. Flow balance means you might have seen that in big supermarkets and all, where the pan is at the bottom and you have a scale, a digital scale at the top. This is a flow balance. And the pan balance is the one mentioned here. This is a pan balance. So tell me what is the advantages of using a flow balance. First thing is, here it is more stable. Stable in the sense, chance for tripling is less. Okay, more stable, less risk of tripling. Tripling means like losing the balance and falling. But here, it can happen. And next thing is here you have a digital scale. That's another advantage. That digital scale is absent here. And for this, if you want to balance something and get the mass, you have to use weights. 1 kilogram weight, 500 gram weights. Those weights are there, stone-like thing. But here, no need of using weights. Okay, is it clear?
Yes, teacher.
Okay.
Yes, teacher.
So, I I hope you are okay with what I have discussed till now. There is a lot to discuss. Like I expected to discuss some, but there's no time. Actually, it's 9 already. You can try them and have the answers also in your past paper book that you have. So you can try them. And if you all need any help, you can contact me. You can send me the question and I'll explain you through a voice note or any means. Okay? I'll give my number. You can note it down if you all need. You can try all these physics questions to study the chapter. Do it. And if there's any doubts, contact me. Okay?
Okay, madam.
It's time for me to end the session now. How was it? I want your feedback. Everyone just type and send me your feedback. And I hope it was useful. Please do try all questions that I have given. And you can compare with your answers in the past paper book, correct it. And then you. So, Jazakallah Khaira for joining. Thank you, everyone.